One thing you mentioned in there was the Vulcan drivers. That's not something that's a thing right now, but what is that Zink thing you mentioned? I've heard other people mention Zink in the context of Vulcan. I've never bothered to probably look into it though.
So Zink is just OpenGL on Vulkan. So
Mm-hmm.
it's a translation layer, just like all the other Vulkan on metal type stuff that there is.
Right.
But it's built into Mesa, and so the idea is that when you get to that level of underlying feature support, um, there is one implementation of OpenGL that handles all this craziness once, and then if you have a Vulkan driver for your GPU, you can just run it on that and not have to worry about all the corner cases. So that's the idea there, and it
Right.
supports like modern OpenGL 4 or something like that. Um, so when we have a Vulkan driver that can handle that, then it might make sense to effectively deprecate the current OpenGL 2.3 driver and just switch to wholesale to Zink on Vulkan.
Mm-hmm.
And that was still used, by the way, the at least the shader compiler that Alyssa wrote, and also all the knowledge we've gotten writing the OpenGL driver. But it's entirely possible that in the future, what we're doing now will be deprecated. But the whole point of this is, the learning experience of understanding how the hardware works and how to implement all these things correctly on the hardware.
Yeah.
And also the shader stuff, which is going to be shared anyway, which is a big part of it.
Mm-hmm.
So, like, it's not wasted work. A lot of people ask that. It's like, why are you doing OpenGL when you just do Vulkan and then do OpenGL on top with Zink? Well, because doing Vulkan to the point where Zink is going to work is going to take a much longer time than OpenGL, and it's a lot less incremental than OpenGL.
Right.
So it makes a lot more sense to figure all this out with OpenGL and go, step by step. And then in the end, if we have to throw it all away, that's fine, because we already we got there, through a path that makes sense and that we could follow to get to that destination. While if you say make a Vulkan driver now from the beginning, it's like where do you even start, right? Like
Mm-hmm.
it's too much stuff has to work at the same time for Vulkan to work.
Right, you wouldn't build a bullet train before building a steam train. You want to have that
Yeah,
fundamental of this. We understand how a train's supposed to function. Then we can build the more complex stuff on
yeah,
top of that.
exactly.
Yep, yep.
And since Vulkan is going to take longer, this means that like today, hopefully this month we can release something, sorry, that people can actually use and get it, an accelerated desktop.
Mm-hmm,
And so
mm-hmm.
that's really important, right? And so yeah, that's the answer to why not Vulkan. But Ella is working on a Vulkan driver.
Mm-hmm.
And that runs. That's already. She's working on Mesa, so it's on the same code base as what we're working on. And I have plans for the kernel side to support all the features that Vulkan needs eventually. And so the idea is that my kernel driver is not going to be upstreamed until we've settled on an interface that should support all the future Vulkan features. So that's one reason that people ask me, is like, when is your driver going to be upstreamed? Linux has a policy that the interface between user space and kernel space can never be broken
Mm-hmm.
in terms of backwards compatibility. And so that makes it very hard to fix that graphics driver design.
Mm-hmm.
Um, but making the good design from the get-go is also hard. So that's also a different road that I'm walking, right? So the UAPI that I have now started off as a prototype, and I've been cleaning it up into something good enough to ship to people. And it has a version check, so if you run a driver that is mismatched with the kernel, it'll just fail. Same as like with NVIDIA and stuff like that,
Yep.
which is not upstreamable, but is what we want for development, because it means we can fix things, right?
Mm-hmm. Mm-hmm.
So whenever this gets released, we would have to tell people, make sure you upgrade all our packages at the same time, because if you upgrade Mesa and don't upgrade the kernel, it's going to stop working. And also when you upgrade, probably new apps will stop launching until you reboot. That's just how it is. Like that's part of being on the bleeding edge of non-upstream kernel driver.
Yep.
But this time I have a version check, so it's not gonna like corrupt or something. It'll just stop working.
Yep.
But like that's the state. That's the work in progress state, right? And then I'm going to be modifying that UAPI to support the features that Vulkan
What is
needs.
a
Like
UAPI?
yeah, UAPI. It's the API between the user space and the kernel
Ah,
space.
yep. Okay. Because you
So
were
I'm
just
gonna.
throwing that term out there without saying what the U was.
Sorry. So yeah, it's called the UAPI, and so that has to be stable when it's upstream. So I'm going to be working on improving that to add things like multiple command queues and things like there's a thing called sync objects, which is where you can set certain things to be dependencies for certain other things. So you can queue work on the GPU and say, when but even across devices, you can say, okay, when a frame comes in from a webcam, then run the GPU render job that'll render this Discord window, which will then enable the compositor to render the whole desktop, which will then enable the display controller to present the frame. And in theory, if all this magically worked as it was supposed to, you could have the CPU asleep the whole time. In practice, that doesn't work unless you have like a lot of very overcomplicated hardware support for all these things.
Yep.
But at least you can have the user space apps asleep and have the kernel do all this chaining and dependency management. And so that's the idea, that the UAPI is going to support these sync objects, they're called, that let you chain things like that and have dependencies. And the kernel will manage, triggering the GPU driver when the webcam driver has a frame and that kind of thing. And so that has to be added for Vulkan because Vulkan needs these for, it also exposes this for the user to use, like in games, like, render this, and once both of those internal frames are ready, then combine them with a post-processor shader, all that kind of stuff. The game still these days needs all the same stuff. And also compute is another thing we're going to have to add, both because a lot of people want it and because we're going to need compute to emulate some GL features that the hardware doesn't support. And then another cool thing is that I don't know if you heard about this. Carl has been working on Rusticle. It's already released in Mesa.
Yes, yeah.
The Rust new OpenGL stack in Mesa. So that should
Very
also pretty
excited
much.
for that.
Yeah, that should also pretty much just work on our driver once we have the basic compute support, because it's all based on the same shared shader infrastructure that Mesa already uses. So I'm also really looking forward to that. And yeah, that also needs UAPI changes to support creating compute command queues in the kernel and submitting jobs and all that. And then also memory management. The Vulkan needs more advanced memory management, which is going to need a bigger revamp of the, how the kernel does all of that. So it's all these changes that we're planning because we need them for future stuff like Vulkan. And they don't necessarily have to wait for the Vulkan driver to be to that point, but I do want to at least have the drivers, using the features so we can prove that they work.
Yep.
And yeah, so that's all the work that's going to be happening before upstreaming, because that's sort of the process that you have to follow.
Yep. Well, you sort of gave like 1,000 different directions to go there.
Sorry.
No, it's fine. The more that you talk, the less that I have to talk.